Hello. So my name is Siddhant Roy and my registration number is 19BC 1181. So today's topic of presentation is Google Glass and related augmented displays. So let's have an introduction. So Google Glass is a brand of smart glasses and optical head-mounted display designed in the shape of a pair of glasses. It was developed by Google X, which is currently known as X, with the mission of producing a ubiquitous computer. Google Glass displays information in a smartphone-like hands-free format and where the wearers communicate with the internet via natural voice commands. Like when they wear the specs, they just have to say OK Google or just tap on the touch screen in the right side of the panel, and the glasses get activated and they perform the functions they're meant to. So for the product timeline, it was released in 2013, but on January 15th, 2015, Google announced that it would stop producing the Google Glass prototype and it would be continued in 2017. In July of 2017, Google announced the Google Enterprise Edition, and in 2019, Google announced the Google Glass Enterprise Edition 2. Currently, the Google Enterprise Edition 2 is only available on a contractual on a professional basis. Like it isn't available to the common public, to the general public. Only doctors or factory workers can make a contract with Google and they can obtain the product. So that's the current scenario. So let's have a small description of what AR is. So augmented reality or AR is an interactive experience of a real world environment where the objects that reside in the real world are enhanced by computer generated perceptual information, sometimes across multiple sensory modalities, including visual, auditory, haptic, somatosensory, or olfactory. So, AR can be defined as a system that fulfills three basic features: a combination of real world and virtual worlds, a real time interaction, and accurate 3D registration of virtual and real objects. Like, suppose in the picture in the left, we can see that this is the famous app called Pokemon Go, which was released a few years back. So as you can see in the user is pointing his phone and the camera is turned on it through the app and he's pointing at this road, and even though there is nothing on the road, in the app we can see a small Pikachu, which is a Pokemon, a game character in the app. The character is standing on the street and interacting with the user and jumping all around. So this is what AR is. So like combining um, the generated virtual environment and the real world environment. So there are many types of AR. One is marker based and one is marker less. So let's discuss about marker based AR. So marker based AR is basically like having a marker in the real world and on basis of that creating the virtual world. Like suppose you walk into a restaurant, and suppose there are 10 items on the menu, and beside each item there is a small QR code. When you open your phone and scan the QR code, you get a AR, and suppose you have the technology using an AR, using AR you can see the AR image, AR like representation of that food item. Like suppose you walk into a restaurant, you have some maybe biryani, and you scan the QR code, and in your phone you can have a AR representation of the food item, and you can turn around with a 360-degree camera and you can see how the dish looks in real life, and on basis of that you can order the item. So this is the marker based system. Like there's a QR code, or maybe there's a marker in the real world upon which the virtual object is built. It may be a QR code or an image or maybe a small um, sign on a piece of paper. It can be anything. And for the other category, the other super category, which is markerless AR, we have four subcategories. The first is location based AR. So location based AR may be AR uh, the object is supposed to be built upon a specific location. Like suppose when you turn on the AR camera and like include the AR libraries and everything. Like suppose when you point to a wooden floor, automatically a bed and a table and chair will be built upon that. The camera will detect the presence of the wooden floor and build all the objects. And similarly, outlining AR is basically outlining something on a real world object. Like suppose you're driving a car, and suppose there are no lines on the road for partitioning the two lanes, and also the walls, boundaries and everything. So this AR can, when you turn on the camera and see the AR app, you can see the boundaries and the lines to separate the lanes, everything inside the app, even though it is not existing in the real life. So that is outlining AR. And similarly, there is superimposition, which is like suppose there's a table in your life and you superimpose your object, like suppose maybe a jug, AR object jug on the table. That is superimposition AR, and that is projection based AR. So let's take a look at the hardware components for AR. So it generally consists of a processor, a display, a sensors and input devices. Modern mobile computing devices like smartphones and tablet computers contain these elements, which often include a camera and micro electromechanical systems, or MEMS to be short. Sensors such as an accelerometer, GPS, and solid state compass, making them suitable AR platforms. So let's look at the thing we are connected to, the software technology. So a key measure of AR systems is how realistically they integrate augmentations with the real world. The software must derive real world coordinates independent of camera and camera images. That process is called image registration and uses different methods of computer vision, mostly related to video tracking. Many computer vision methods of augmented reality are inherited from visual odometry. An onogram is a computer generated image that is used to create AR. So, like I explained before, it is based on real world coordinates. So there are this methods consist of two steps. Let's look at step number one. So step number one is detect interest points, fiducial markers, or optical flow in the camera images. This step can use feature detection methods like corner detection, blob detection, edge detection, or thresholding, and other image processing methods. Like as you can see in the image in the right, like if the like suppose some person has opened the Google Maps and they want to go to a specific location, and they're using the AR in the app. So as soon as they reach in the location, there's a small destination marker in that place along with a shadow, so you can see the quality of the AR augmentation. So like there's a destination marker in that place, and the user can like exactly pinpoint, okay, I'm in the location. So this was the step number one, and the next step is the second stage. It restores a real world coordinate system from the data obtained in the first stage. Some methods assume objects with known geometry or fiducial markers present in the scene. In some of those cases, the scene 3D structure should be calculated beforehand. If part of the scene is unknown, simultaneous localization and mapping can map relative positions. Like suppose if we look at step number one, like if the user opens the camera and detects this road and all the images, the software will detect all the points and it will identify the lane on which the user is walking, and then pinpoint the destination marker. Like the software is recognizing using CV, like I said in the previous slide, like the destination marker is exactly in front of the building and on the lane. It is not on top of the car or on the street, or it is flying in the sky. It has pinpointed the exact location it should be at. So let's look at the techniques of presenting the augmented content. So there are three types: hand attached, handheld, and spatial. You can see the diagram. So let's look at retinal display, or sorry, hand attached. So hand attached is that type of presentation where the user or the users wear a device like the AR devices or the VR devices we get nowadays. Like they have to wear a mounted display in and using their movements and everything, the machine will detect all the movements and simultaneously move the environment. So it's a head mounted display and the image is formed exactly on the retina. And the second type is handheld, like the Pokemon Go app which I discussed. So handheld is using your maybe your phone or laptop or some other device which can be handheld. And the spatial is a very fascinating and new technology where the AR is displayed using the plasma available in the air, and it uses spatial see-through display. It's a very interesting technology. So let's look at optical design system. So there are two primary optical design systems that are widely used in AR and VR displays. The first, non-pupil forming. Non-pupil forming is made up of a single lens. This type of architecture uses a single magnifier to directly align the rays of light from the display panel. And the non-pupil using an effect known as pincushion distortion. In pupil-forming architectures, another lens that produces a barrel distortion is used to nullify the effect. You can see the diagrams for both the types of architecture. So let's move on. So let's focus on the features of Google Glass, the first product, the first smart glass which was released. Even though it wasn't much of a success at that point because it was too ahead of its time, currently it is a very useful product and a very widely known product. So let's look at the features. The first feature is a touchpad. A touchpad is located on the side of the Google Glass on the right side, allowing users to control the device by swiping through a timeline-like interface displayed on the screen. Like they can, if you can see me, it's on the right side and they can tap and move forward and move backward to interact with the augmented display. The next feature is a small camera in the frame, which is attached to the frame. The Google Glass has the ability to take 5 megapixel photos and record 720p HD videos. And Google Glass Enterprise Edition 2, the recent version, has an improvised 8 megapixel 80 degree FOV camera. So, and also the display. The Explorer version of Google Glass uses a liquid crystal on silicon based on an LCOS chip from Himax, field sequential color system, LED illuminated display, and it also has voice activation. Other than a touchpad, Google Glass can be controlled using just voice actions. To activate glass, wearer tilt their heads 30-degree upwards, which can be altered for preference, or simply tap the touchpad and say OK glass, and the glass turns on and the user can interact with the interface. So I would like to conclude by saying that these displays and imaging technologies are growing rapidly and are making the VR experience even more functional and realistic and enjoyable. The possibilities are endless, and who knows, in a matter of years, flat panel based HMDs might just become a thing of the past for many AR devices. Like this year in 2021, in this month or the next month, Apple has declared that they'll be launching Apple Glass, which is their version of a smart glass. And also, if I'm not wrong, Samsung is also supposed to launch their AR glasses or the smart glasses this year. So this was my what I learned from my research, and thank you for staying till the end. Have a great day.